So, according to math, the limit as x approaches a of fx equals L. This limit exists if this is true. So you might be thinking to yourself, what on earth is that? That is not English. There's not a single word on this definition. Well, that's what I thought when I saw this for the first time in my classroom. But over the next few videos, I'm going to help explain to you and put these bunch of, Greek letters into actual meaningful words. I'm going to explain to you what this all means. And hopefully by the end of the video, you should be able to understand this epsilon delta definition of a limit more clearly. Okay? So, let me break down to you what this means. So, I have zoomed in into a diagram that I found online. It was from brilliant.org. And basically, what the epsilon delta definition of limit is saying is that if we choose any value of epsilon that's greater than 0, okay, we should be able to find a value of delta such that any x value from, x naught minus delta to x naught plus delta, or actually in the epsilon delta definition, we wrote a instead, so I'll just replace that with a. So every value between a minus delta and a plus delta should be able to be plugged in into f of x, right? And yield a value that's in between L minus epsilon and L plus epsilon. So if we are able to find and calculate a delta for every single epsilon that satisfies this condition, then that means the limit exists. Okay? So how do you go on about proving this? Okay, because this is pretty complicated, and this is probably something new because I've never seen something like this in high school math. Well, we'll see that in the next slide. So basically, let's prove that the following limit exists. The limit as x approaches t3 of 4x minus 1 equals 11. If you graph the function, you'll see that the limit actually does exist. But let's take a look at what this looks like using the epsilon delta definition. So you can see that for all epsilons, there exists odd delta, which we'll just, a minus delta and a plus delta are just shown as the red lines. There always exists odd delta such that every x value between a minus delta and a plus delta can be plugged in into fx to yield a value that is between L minus epsilon and L plus epsilon. You see that doesn't matter what epsilon is, as long as it's greater than 0, you can always find a delta, which means that a limit does exist. So let's do that like rigorously using math, not just using a video to prove it. Okay, so let's look at how to algebraically prove that this limit exists. Okay, so our first step is to find delta, okay? And remember, for the epsilon delta definition of a limit, we need to find a delta that works for any value of epsilon greater than 0, all right? So that means we have to define your delta in terms of epsilon, okay? So how do we do that? Well, we first start with f of x minus L is less than epsilon, okay? So that's, in this case, that's just 4x minus 1 minus 11 is less than epsilon, okay? That's the first step, okay? And now we have to find delta, okay? Remember, the absolute value of x minus 3 is less than delta. Okay, I'm not very good at drawing delta, but I hope it's good enough. So, if we want to solve for delta, we can try using this and manipulating this into something that looks a little more like absolute value of x minus 3 is less than delta, okay? So how do you do that? We can rewrite this as 4x minus 12, or absolute value of 4x minus 12 is less than epsilon. We can factor out a 4, and we get x minus 3 is less than epsilon, okay? So now we can, now that we see that x minus 3 is less than epsilon divided by 4, okay? So now we can set epsilon divided by 4 as our delta, since we know that absolute value of x minus 3 is going to be less than epsilon divided by 4 for this condition to be true, for fx minus L to be less than epsilon. X minus absolute value of x minus 3 has to be less than epsilon divided by 4. So now we can just set delta equal to epsilon divided by 4, okay? So now, how do we prove this? That epsilon divided by 4, if we set delta equal to epsilon divided by 4, how do you prove that the limit exists? Okay, well, I'm going to erase everything real quick. We're going to start off with this, okay? We're going to start off again with fx minus L, okay? Now, we're going to rewrite this as absolute value 4x minus 12, okay? That equals this, which equals 4 times absolute value of x minus 3. All right? And remember, we said delta to be greater than x minus 3, or absolute value of x minus 3. So we're going to say that that is less than 4 times delta. 4 times delta. Okay? And remember, we set delta to be epsilon divided by 4, okay? So that's just equal to epsilon, because 4 times epsilon divided by 4 is just epsilon, okay? So we just proved that f of x minus L is less than epsilon if we set delta equal to epsilon divided by 4. And since we found the delta, since we found that no matter what epsilon is, if delta is equal to epsilon divided by 4, that epsilon delta condition that we had, that every x value between a minus delta and a plus delta will return a value that's between L minus epsilon and L plus epsilon, that's always going to be correct now. So we just proved that this limit exists. That is pretty complicated, but that we're just getting started.